Echostar Mobile, and SSL. You are now seeing live the ILS Proton launch vehicle.
Watching launch of Echostar 21, I think it is. Yes.
Echostar 21 will be launched from Launch Pad 24 at the Baikonur Cosmodrome. This will be the 6th satellite to be launched on Proton for Echostar and the 29th SSL-built satellite to be launched on Proton. Of the 413 Proton missions since 1965, this will be the 94th mission for ILS and the first commercial mission in 2017.
Please no.
Liftoff is scheduled for June 7th at 9:45 p.m. at Echostar in Denver, Colorado, and 8:45 p.m. at SSL in Palo Alto, California. 11:45 p.m. here in Washington, D.C., which is June 8th, 9:45 a.m. in Baikonur, Kazakhstan. The countdown to the launch of Echostar 21 begins now.
Fun fact about Denver. The airport was designed by the angel NASA. I'm joking if that is an actual thing. Look it up. Isn't this really down? I don't know. It's not even a lot more later. Huh. It's from a landing system. Anyway, Echostar 21. I've just been sitting in front. Okay.
Hello, I'm Jennifer Gladstone, your host. Welcome to our live coverage of the ILS Proton launch of the Echostar 21, the first Proton launch of 2017. Joining me here is Tom Carroll, Vice President of Sales for ILS, also known as TC. And TC will now give us a quick update on what is happening now at the launch site. TC?
Hi, Jennifer. Thank you. The current status from Baikonur is that all systems are go for launch as we count down to the launch of Echostar 21. Let's take a look now at today's Proton mission profile that was optimized for the Echostar 21 mission requirements.
This is the Geosynchronous Transfer Orbit, or GTO, mission profile for Echostar 21. The Proton M launch vehicle will utilize a 5-burn Breeze M mission design and liftoff from Pad 24 at the Baikonur Cosmodrome in Kazakhstan with the Echostar 21 satellite on board. The 191-foot or 58.2 meter tall ILS Proton is a 3-stage rocket with restartable upper stage. The Proton's first 3 stages propel the orbital unit, consisting of the Breeze M, payload adapter system, and the Echostar 21 satellite, into a suborbital trajectory during the first 10 minutes following launch. After that, the Breeze M takes the spacecraft through the parking, intermediate, transfer, and geotransfer orbits during the remaining 9 hours of the mission. The liftoff phase begins with the ignition of the 6 powerful first-stage engines that generate 2.4 million pounds of thrust at sea level. As the ILS Proton lifts off from Launch Pad 24, it immediately executes a roll maneuver to align its pitch axis with the flight launch azimuth of 61.3 degrees as it travels in an east-northeast direction across Kazakhstan towards the Pacific Ocean. The first stage engines fire for about 2 minutes, during which the ILS Proton experiences maximum dynamic pressure. Soon after that, the first stage separates from the second stage. As the second stage ignites, 540,000 pounds of thrust is generated for 3.5 minutes, and then stage 2 separates, allowing the third stage engine to fire and generate 131,000 pounds of thrust for 4 minutes. Soon after third stage ignition, the payload fairing, consisting of 2 symmetrical payload fairing halves, separates and is jettisoned from the launch vehicle. Having traveled from Baikonur to eastern Russia at 51.5 degrees north latitude, Stage 3 separates from the orbital unit, which is now moving at about 7,300 meters per second, or 4.5 miles per second relative velocity in suborbital trajectory. At this point in the mission, the Breeze M upper stage, designed to inject payloads into a variety of orbits, takes over. The first of 5 Breeze M burns in Echostar 21's GTO mission occurs about 1.5 minutes after the third stage separation. The purpose of this first Breeze M burn is to achieve a low Earth circular parking orbit of 170 kilometers perigee and 177 kilometers apogee. The first burn spans from Siberia to Russia's east coast. 52 minutes after the main engine cutoff of its first burn, or MECO-1, the second BRIES-M burn begins, placing the spacecraft into an elliptical orbit called the intermediate orbit. Perigee is increased to 270 kilometers, and apogee to 5,000 kilometers, and an inclination slightly reduced to 50.3 degrees. This nearly 18-minute burn spans from the South Atlantic 800 miles east of Rio de Janeiro to Libya. Approximately 2 hours later, in a 19.8-minute sequence, the third BRIES-M burn is executed, the auxiliary propellant tank, or APT, is jettisoned, and the fourth BRIES-M burn is completed, resulting in a transfer or more elliptical orbit. In the transfer orbit, the apogee is greatly increased to 35,807 kilometers, more closely matching geosynchronous altitude, while perigee is slightly increased to 436 kilometers, and inclination reduced to 49.1 degrees. The third and fourth BRIES-M burns take the spacecraft from the South Pacific 200 miles west of Chile to 300 miles west of Morocco. The BRIES-M performs various attitude maneuvers during the coast phases between burns, allowing Echostar 21 and the BRIES-M to be exposed to the warming rays of the sun at pre-programmed solar illumination angles, designed to meet power and thermal requirements. About 5 hours later, the orbital unit performs a large plane change maneuver with a significant decrease in inclination from 49.1 degrees to 30.5 degrees during the fifth and final BRIES-M burn. Apogee is slightly decreased to 35,786 kilometers, and perigee increases considerably to 2,300 kilometers. The fifth BRIES-M burn lasts approximately 4.5 minutes. About 15.5 minutes after MECO 5, Echostar 21 is separated from the BRIES-M, having reached its targeted GTO orbit near the east coast of Africa. The total mission duration is 9 hours and 13 minutes in length.
Remember, you can stay up to date on the status of the mission by visiting the ILS website, ilslaunch.com, by following us on Twitter, and by liking us on Facebook. So, TC, you've seen the Proton vehicle as you've witnessed a number of the live launches in Baikonur. What are your impressions today?
The rocket is quite impressive to view at the launch pad. All four stages together with the payload fairing is about 58.2 meters or 191 feet tall. The launch vehicle has a dry mass of 48,000 kilograms dry and 698,000 kilograms wet mass. The dry mass is the weight of the rocket without fuel. The wet mass is fueled for launch.
You mentioned fairing, so talk to me about what the fairing is and what purpose it serves.
The fairing is the lead part of the rocket that is designed to protect the satellite. During the first few minutes of the mission, the rocket is accelerating through the lower atmosphere. Forces are created by that acceleration that could damage the satellite if not protected. After the rocket reaches a higher altitude, the atmosphere is thinner and the pressure is greatly reduced. So we can jettison the fairing, which reduces roughly the 2,000 kilograms of mass.
Thanks, TC. Echostar 21 is a state-of-the-art S-band satellite designed to provide mobile connectivity throughout Europe. The spacecraft, based on SSL's 1300 bus, will be located at the 10.25-degree east orbital slot. Here's a little more now about SSL and the performance, power, and reliability of the Echostar 21 satellite.
Two alarms were when the
SSL, a leading provider of innovative satellites and spacecraft systems, built Echostar 21 for Echostar Corporation, a premier global provider of satellite and video delivery solutions. Echostar subsidiary Echostar Mobile Limited will use capacity on Echostar 21 for mobile voice and data communications throughout the European Union and neighboring countries, including the United Kingdom. Echostar Mobile provides commercial wholesalers with a new advanced network for reliable IP-based mobile satellite services for voice and narrowband data connectivity in Europe. Echostar 21 will be located at 10.25 degrees east longitude. The satellite has an 18-meter antenna reflector built by the Harris Corporation that enables the use of small mobile terminals on the ground. SSL and Echostar have a long history of working together on some of the world's most powerful and advanced satellite systems. Over the past 3 decades, SSL has built more than a dozen satellites for Echostar and its partners. It takes teamwork and trust to develop a complex satellite like Echostar 21. SSL would like to thank Echostar, ILS, and the many technicians, engineers, and managers who made a commitment to building and launching this exceptional satellite.
And we are now just 5 minutes to launch. As this mission is a bit of a departure from other missions ILS has performed for Echostar, let's learn a little more about the mission's unique nature in this video provided by Echostar.
Okay, I'm confused. What do you mean different?
Echostar Corporation is a premier provider of satellite and video delivery solutions. Headquartered in Englewood, Colorado, and conducting business around the globe, we are a pioneering communications technologies through our Echostar satellite services, Echostar Technologies, and Hughes Network Systems business segments. These branches generate over 2.67 billion euros, that's $3 billion US in annual revenue. A leader in satellite communications, Echostar manages the world's fourth largest commercial geosynchronous fleet of 24 satellites. Echostar provides communication services worldwide for media and broadcast organizations, direct-to-home providers, enterprise customers, and government service providers. Echostar's newest satellite, Echostar 21, is owned and operated by Echostar. It will be located at the 10.25 degrees east orbital slot. This state-of-the-art satellite will provide S-band mobile capacity to subsidiary Echostar Mobile Limited, which will offer mobile satellite services coverage across the European Union. Echostar's team will manage flight operations for Echostar 21 using its primary satellite Earth station in Grisheim, Germany, and a secondary satellite Earth station in Rambouillet, France. Also supporting Echostar 21 is subsidiary Hughes Network Systems, which will use 16 European calibration Earth stations to maximize spectrum efficiency with sophisticated ground-based beamforming technology.
So Hughes' innovative ground-based beamforming technology allows us to get the most efficient use of spectrum on Echostar 21 through its frequency reuse capabilities. And this enables us to deliver increased capacity in the areas that need it most.
Headquartered in Dublin, Ireland, Echostar Mobile Limited is an EU-wide licensee for an integrated mobile satellite service network with a complementary ground component. Using a portion of the capacity on Echostar 21, Echostar Mobile Limited will provide mobile satellite services throughout the European Union so that businesses, consumers and government agencies can stay connected with voice and data services. Working with commercial communications wholesalers, potential mobile applications include voice-over internet protocol, web browsing and email. The communications network offered by Echostar Mobile Limited has the potential to benefit new and existing markets and underserved areas, including public safety and disaster relief.
The launch of Echostar 21 is very exciting for Echostar Mobile here in Europe. Following the launch of the satellite, we'll be providing services to the entire European Union, and in partnership with strategic wholesalers, we'll be delivering services into government agencies, into consumers, as well as into businesses across the entire European Union.
Echostar would like to acknowledge the contribution of our partners at SSL, ILS and Krunichev, who have all helped make the Echostar 21 program a success.
And now TC will take us to the launch of Echostar 21 aboard an ILS Proton. TC?
Thanks, Jennifer. The current weather conditions in Baikonur are some light high clouds coming in, but we're all go for launch. As Echostar 21 awaits liftoff aboard the ILS Proton on Pad 24 at Launch Complex 81 at the Baikonur Cosmodrome, we are all thinking of the impressive amount of time and effort by ILS and our partners at Echostar, SSL, and Krunichev. From conception to design to manufacture to launch and finally into commercial service, this is a large-scale operation involving precision planning and detailed execution by the entire team. Mission teams are in their place in the bunkers, control rooms, ground stations, and communication centers around the world. Long-term ILS Mission Director Russ is in the underground launch pad near Pad 24, and in my earpiece with live updates from Baikonur is Judy Opp, our ILS Program Integrator. And we are go for launch. As we move through the launch, you will notice our new Mission Control Progress bar on the left side of the screen which will advance along with the mission. And now we're about 30 seconds to launch, T-minus 30 seconds. And now let's wait together for the launch of the Echostar 21. It looks a little cloudy there today, as you can see, Jennifer. But I think the screen might be a little darker than it actually is there, depending on cameras and feeds. And now we'll step aside for the launch. And we have ignition. We have positive thrust and liftoff of the ILS Proton launch vehicle with the Echostar 21 satellite on board.
It's hilarious how everybody's doing that.
About 10 seconds after liftoff, the launch vehicle performs a roll maneuver to align the launch vehicle pitch axis with the planned northeasterly launch azimuth. The vehicle will soon experience maximum dynamic pressure, or max Q, which is the aerodynamic force on the vehicle has peaked. For Proton, the max Q occurs about 62 seconds after liftoff at a velocity of Mach 1.6. Visible condensation that appears to be a stream of smoke can be observed when the conditions are favorable like today, right now on screen. Everything seems to be proceeding nominally as the vehicle ascends over the cosmodrome in a northeasterly direction in suborbital trajectory along the route, which provides a parking orbit inclination of 51.6 degrees. We're coming up on the first stage separation from the second stage. That is set to occur at 2 minutes into the flight. In order to maintain a constant level of force, the second stage engines ignite prior to the separation from the first stage. Rockets heading downrange now. On a clear day like today, launch site observers will be able to see a halo effect as the second stage engines ignite.
Separation, apparently.
And we have confirmation of ignition of the second stage and a good separation from the first stage.
Second stage burning nominally.
We have confirmed of the planned level of thrust of all 4 second stage engines. The second stage will operate for about 3 minutes and 26 seconds. The next key mission milestone will be separation of the third stage from the second stage at L plus 5 minutes and 26 seconds. About 20 seconds into the third stage operation, the density of the atmosphere has reduced so that the payload fairing can be jettisoned. As mission proceeds and the launch vehicle travels from Kazakhstan into the Russian territory, our viewers will notice some brief, planned delays in our reporting of key milestones of the mission, as the telemetry has been to be relayed through multiple ground stations and facilities.
The first burn of the Breeze M upper stage is scheduled for completion about 16 minutes into the flight. Our live coverage will conclude shortly afterwards with mission updates posted to the ILS website, Facebook, and Twitter pages thereafter.
Yeah, you don't post on Facebook.
Now let's take a chronological look at Echostar 21's journey to launch.
The journey from concept to launch takes about 2 years for a commercial satellite, beginning with the satellite operator and the manufacturer's designs, then proceeding to the integration and launch. Each launch campaign begins with the arrival of the spacecraft and the crew into Baikonur. The satellite arrives via the massive Antonov cargo jet at the Yubilini airfield in Baikonur and is carefully offloaded to a rail car from the Antonov's cargo bay. The spacecraft makes a 6-hour rail trip from Yubilini to the launch processing facility in Baikonur in a thermally controlled environment. Systems tests and other operations to include fueling of the spacecraft are performed by the crew in the high bay. At this point, joint operations begin. The skilled, experienced teams work side by side to bring all the flight hardware together. In Hall 101 at the Baikonur Cosmodrome, the satellite is mated to the Breeze M restartable upper stage. It is then rotated horizontally to be encapsulated in the payload fairing. Joint testing accompanies each mating activity to verify proper functioning of the many components. From this point forward, the spacecraft, fairing, and upper stage are referred to as the ascent unit. The booster stages are mated to form the entire assembly of the Proton Integrated Launch Vehicle in Hall 111. The integrated launch vehicle is then fueled at the Breeze M fueling station. After Breeze M fueling, the rocket rolls to the launch pad. Slowly and carefully, the hydraulic erectors move the rocket from a horizontal to vertical position to be placed in the mobile service tower. The mobile service tower moves in to provide services and accessibility to the launch vehicle and the spacecraft. As a tribute to Yuri Gagarin, the first man in space, Proton is rolled out to the launch pad at precisely 0630.
Well, we've received some great photos from the launch team. TC, take a look and take us through, explain what some of these photos are for us.
Well, let's see what the photos are here. I haven't seen them yet, but I can tell you that the mission is proceeding nominally right now. I've got reports of everything going well on the second stage. The first picture you're seeing is actually the Proton being moved out to the launch pad. The launch vehicle actually is moved out backwards. The launch vehicle backs up to the launch pad with the vehicle, with the aft end towards the launch pad.
Because otherwise it would be very difficult to put it upright. It's a bit of logic there, which a lot of people do lack.
I just got confirmation of second stage completion and third stage separation.
Oh, that's hilarious. The progress bar is there, but it barely works.
And the payload fairing. So the photographs, let's see what else we have here. This one is in its progress out towards the launch pad. You can see security and fire and all being careful of everything's going along. You can see also the people walking along as the vehicle moves at about 5 kilometers per hour. This is as it's approaching to the launch pad. Everybody making sure everything. You can also see the connections at the bottom there. That will connect to the launch pad for electric connections and all the commands. Next photo, if we have any more. Or this one here is a picture of the launch vehicle just as it's arriving to the pad. The green area you can see is the clamp system that will hold the launch vehicle in place. When it's erected onto the pad, this will be what holds the launch vehicle in place for launch. You can see in the further areas the mobile service tower. That'll be moved into place and brought in around the launch vehicle for access to the different levels of the launch vehicle.
Well, that's a really oddly...
Just got reports from Baikonur. Everything's going nominal on the mission right now. Another launch vehicle picture here. Now this is at the pad. Strange photograph, but it looks from its design, and as they're bringing the service towers around and the different levels on the launch service tower so people can get up to the different access.
Very odd. What's the weird distortion of photos?
Okay, next let's go back. Payload fairing jettison occurs at a velocity of about 4,600 meters per second, or 2.9 miles per second, and an altitude of 138 kilometers. Our next major milestone happens in a few minutes. This will be the separation of the Proton's third stage from the Breeze M upper stage.
We've talked about it a little today, and we've given some of our viewers a baseline knowledge of the ILS Proton. Now let's take a more in-depth look at the Heritage Proton launch vehicle. All Proton rockets are expertly manufactured at Khrunichev in Moscow and then transported to Baikonur.
Oh, come on, you haven't had problems until now. Why would you have? Can you refresh?
Proton is between 184 and 191 feet, around the same height as a 19-story building. Its gross liftoff weight can be around 705,000 kilograms or 1,554,000 pounds, depending on payload and fuel weights. Proton's initial launch was on July 16, 1965, with the Proton 1 spacecraft. If we begin our in-depth look at the Proton in a manner chronologically consistent with the launch phases, we see that the first stage consists of a central tank containing the oxidizer tank surrounded by 6 fuel tanks. Each fuel tank also carries one of 6 RD-276 engines that provide first stage power. Total first stage vacuum rated level thrust is 11 meganewtons or 2.5 million pounds of force. The second stage is a conventional cylindrical design and it's powered by 3 RD-210 engines plus 1 RD-211 engine. It develops a vacuum thrust of 2.4 meganewtons or 540,000 pounds of force. The third stage is powered by 1 RD-213 engine and develops thrust of 583 kilonewtons or 131,000 pounds of force. It has a 4-nozzle vernier engine that produces thrust of 31 kilonewtons or 7,000 pounds of force. Guidance, navigation, and control of the Proton M during operation of the first 3 stages is carried out by a triple redundant closed-loop digital avionics system mounted in the Proton's third stage. The Breeze M upper stage is powered by 1 pump-fed gimbaled main engine that develops thrust of 20 kilonewtons or 4,500 pounds of force. It is composed of a central core and an auxiliary propellant tank which is jettisoned in flight following depletion. The Breeze M control system includes an onboard computer, a 3-axis gyro-stabilized platform, and a navigation system. Finally, the payload fairing. It consists of 2 symmetrical payload fairing halves and a static envelope diameter of up to 3.87 meters. There are multiple payload fairing designs presently qualified for flight, including standard commercial payload fairings developed specifically to meet the needs of ILS customers. The payload fairing for commercial launches aboard an ILS Proton separates at the nose cone in a planned maneuver, leaving the Breeze M and the spacecraft together, known as the orbital unit, to continue the journey to its planned orbit.
Alright.
That's an at-a-glance look at the Proton and its stages.
So, TC, can you give us an idea of how you learn of the satellite's health during and after the launch?
Oh, yes, of course. During the coast period between the 4th and 5th burn, SSL will be able to communicate with the Echostar 21 satellite while it's attached to the Breeze M. SSL will download status of their satellite through the SSL ground stations.
So how is this launch different than other Echostars?
The majority of satellites that we've launched for Echostar are the direct-to-home entertainment in North America. This satellite will be used by a subsidiary Echostar Mobile to provide its advanced network for voice and data services throughout Europe.
So talk to me a little bit about the satellite's capabilities.
Echostar's video before the launch covered this pretty well, but in a nutshell, Echostar's mobile satellite-based platform, designed and developed by Hughes, leverages the ETSI GMR1 3G air interface standard, enabling wireless mobile devices to communicate over the satellite. The portable data terminal, also developed by Hughes, is designed for two-way communication, acting as an MSS hotspot that supports all advanced IP services, providing 3G and 4G compatible voice and narrowband data services. While we were on doing that, I did get confirmation of third stage completion, separation of the ascent unit, and the firing of the first burn of the Breeze M. Everything looks nominal on the mission right now.
Very good. Thank you, TC. The Breeze M upper stage is designed for injecting payloads into a low, medium, or high geosynchronous orbit. The main engine can be restarted 8 times during flight and allows precision injection of the spacecraft into orbit. Let's learn more about Proton's technology and its role in the Echostar 21 mission now.
The orbital unit, consisting of the spacecraft, together with the adapter, separation system, and Breeze M, travels at approximately 7,300 meters per second at the moment of separation, or more than 16,000 miles per hour. The Breeze M ignites for its first burn about 1.5 minutes later and lasts about 4.5 minutes. About 4 minutes after the first main engine cutoff, or MECO 1, the vehicle is scheduled to go out of range of ground tracking stations. After about 70 minutes, we will reacquire the signal prior to the second burn of the Breeze M.
Now, I know that in addition to the Heritage Proton Breeze M, ILS has other product offerings. Can you tell us a little bit about those, please?
Sure. Over the past year, ILS has introduced and contracted for 3 new launch service offerings. We have the Angura 1.2 for LEO missions. We've contracted for a dual launch of 2 satellites on a Proton Breeze M, the same launch vehicle used today for the Echostar 21 mission, and we've introduced the Proton Medium. The Proton Medium was the response from Khrushchev to provide launch service capability to mid-range mass properties of communication satellites. Many satellite operators are building electric or hybrid propulsion satellites for operations. The overall goal was to reduce price and performance to match the projected demand. We signed our first contract for Proton Medium, and we're working with many other potential customers for future launch services.
All right, TC. Now, at this point in the mission, the Breeze M has separated from the Proton's 3rd stage, and we're waiting for confirmation that the Breeze M has started its main engine. So what can you tell us about the mission status now?
Well, the status is that everything's proceeding nominally as planned, down its track where it's supposed to be going. The 1st stage engine, I can confirm that that is firing, and the Breeze M's doing its job of taking the satellite on into orbit. This Proton launch vehicle has completed the ascent mission, and now the Breeze M will begin the journey to deliver the Echostar 21 satellite to the planned separation point at an apogee of geostationary satellite orbit altitude.
The Echostar 21 mission team is represented in this combined greeting from Baikonur by ILS Program Director Russ Prytula, Khrushchev Program Director Pavel Pasegov, Echostar Launch Vehicle Interface Specialist Mike Thie, and SSL Launch Vehicle Mission Manager Jeremy Ekoff.
Hello to everyone from the Baikonur Cosmodrome. Yes, we really are here, and this really is the Echostar 21 launch campaign. There were a few bumps along the way, but this campaign is now in full swing.
It's always a great day at the Cosmodrome when we come out here and look up at the Proton rocket, fully erected out on the pad, and the perfect June weather kind of makes it even better.
Echostar 21 is the 6th spacecraft we're going to launch for Echostar Corporation. While working on this program, we met many old friends as well as new, young, and gifted engineers.
These experienced teams have performed like clockwork, and this campaign has moved forward under challenging circumstances.
This latest and greatest Echostar spacecraft is a state-of-the-art S-band system, which is being launched for Echostar and its subsidiary, Echostar Mobile Unlimited. Its primary purpose is to provide mobile connectivity through Europe. The spacecraft has been built and tested and prepared by our friends at Space Systems Loral, and just so happens to also be the heaviest commercial payload to date on a Proton, nearly 7,000 kilograms.
We'd like to thank ILS, Khrushchev, Senki, and all the other many allied companies here at the Cosmodrome for making today possible.
On behalf of my colleagues and myself, I would like to thank the participants of our launch campaign, Echostar, ILS, SSL, RUAG, and many others, and to wish good luck to all of us.
And to everyone at Echostar, Derek and Anders and Darren especially, thanks for giving me this opportunity to represent your company at the launch base. It's truly been a pleasure. And to everyone back home, Cindy, kids, thanks for the support as always, and I'll see you soon. Thanks.
Our planned launch date is the birthday of the daughter of Valentina Tereshkova. You may ask, who is Valentina Tereshkova? What does she have to do with today?
Fuck you.
Valentina Tereshkova was an orphan born in a Russian provincial town.
She was the first woman in space.
Quit school to support her family as a textile worker, and with a lot of hard work, dedication, and probably tremendous good luck, was chosen to become the first woman in space in June 1963. What does it have to do with it today? I would hope that young people watching this program will emulate their elders, people who have come before them, and perhaps be inspired by this launch to do something great with their lives.
I'm proud to say that I've been involved with 5 Echostar launches on Proton, and I would like to give special thanks to Echostar, SSL, Khrushchev, and all the teams that have hung together to make this particular launch possible. It really has been a pleasure. Now let's do launch. As always, go Proton, go Breeze M, go Echostar 21.
One of the questions that we often get at ILS is what happens after the Proton completes its mission with respect to the satellite. So, TC, can you explain for us?
Sure. After spacecraft separation, Echostar and SSL will take over operation of the satellite. The spacecraft will execute a series of planned operations which will include solar array deployment, reflector deployment, and a series of apogee engine firings. These series of firings of the satellite engine will bring the orbit inclination down to 0 degrees and raise the perigee to match the apogee, resulting in a circular geostationary orbit over the equator. Following a period of in-orbit testing, the spacecraft will be positioned and placed into commercial service at the orbital slot of 10.25 degrees east longitude and begin to provide additional S-band mobile capacity to Echostar's European subsidiary, Echostar Mobile.
We now are at the point in the mission where the BRIES-M upper stage has completed its first burn. 4 more BRIES-M burns for a total of 5 are required before spacecraft separation. So, TC, what is the current status of the Echostar 21 mission?
Well, while you were speaking, I actually got confirmation of the first burn completion of BRIES-M. Everything's going along nominally as planned and going very well. So far, so good.
That's what we like to hear.
All telemetry reports confirm the mission is proceeding as planned and moving along the flight path. So far, so good. That's what I like to say.
Absolutely. Well, this is where our live coverage of the launch of the Echostar 21 satellite concludes. Please continue to check back with us through ilslaunch.com and the ILS Facebook and Twitter pages for regular mission updates. I'd like to thank TC for co-hosting today's launch with me today, and from Baikonur, ILS Program Director Russ Prytula for mission updates from the Cosmodrome.
You're welcome, Jennifer, and thank you. Go BRIES-M, go Echostar 21.
So to all of the teams working on the Echostar 21 mission and our partners and customers around the world, we thank you for watching along with us.
Seeing as that was launched Echostar 21 atop Proton BRIES-M, this is a replay of that launch. Also, Proton's long-awaited return to flight. 1 button 25. See you next time.